Super. So let's get this going. The next speaker, ladies and gentlemen, boys and girls, is someone who studied in Bengaluru. How many of you love Bengaluru here? Make some noise. Thank you, thank you. I just wanted to hear something for my city. So Zahoor Muhammad is our next speaker. He's a committer at Shardeum with over 25 years of experience under his belt. Give it up for him, give it up for him. He might be a lot more senior to you, but boy, this man is really cool. I've had a conversation with him. He has a work across various domains, including telecom, payment, and big data, and held positions of architect at companies like PayPal and Ericsson. And he's been in the blockchain space and very internationally known from 2016. He's worked with Ethereum Foundation and Swarm Foundation in the past. So if you guys are lucky, he might give you some Eid. Sir, for Eid milega aaj?
Sorry?
I said, would we get some Eid today?
No.
No. So ladies and gentlemen, give it up for louder, come on guys, come on. Zahoor Muhammad, your keynote speaker from Shardeum. Thank you.
Thank you very much. First of all, I would like to thank the conference organizer for inviting me, and second, I would like to, I like his t-shirt. I like his shirt. So yeah, it's a compliment for him. Do we have our slides? Good. So as I said, my name is Zahoor. I'm actually a committer in Shardeum. We are actually building India's first L1 system, blockchain, right? Okay, so you might say, oh no, not again. One more L1. Why do we need? All these kinds of things will come into your head. I would say bear with me for next 30 minutes or so. I'm very notorious to exceed time. And then let's see, and then you can make decisions. I'll be in our booth. If you have more questions, you can actually come there. Okay, so as I said, my name is Zahoor. I have worked for close to 25 years. I remember when we actually put 58 independent stickers in our final year. So now it's actually 75th independent states going to come. So it's really cool to see that. So yeah, so I'm actually I've worked in a lot of things before, but I'm actually basically a distributed systems and storage guy, right? So I have built distributed systems for telecoms and a lot of other payment systems and all these things, and mostly working on storage. Okay, so I came in, I was actually, like others, pulled into the, blockchain hole somewhere around 2016. I wanted to slowly go and contribute to systems, so I started to do that. So that's where I actually picked Swarm. Swarm was like, was actually part of Ethereum Foundation. So I started to work. So I decided that I'll do a full-time switch there, and I decided to work with Ethereum Foundation. So in Ethereum Foundation initially, I don't know how many people know, Ethereum Foundation had actually 3 goals initially: to build a consensus engine, to build a actually decentralized storage engine, and then a decentralized communication engine called Whisper, right? So what happened is that the first one grew so big, the other ones were gone. And then we were sort of incubated in Ethereum for some time, and we came out, we built systems and all these things there. But the initial plan was to have all this, all this data that you download to push into actually a decentralized system, which is actually provable inside a contract, so you don't have to do a sync. That was the original idea, right? And then I actually joined Prismatic. Prismatic Labs has its own client called Prism, which is a very well-known ETH2 beacon chain client and a validator. So I worked on Ethereum, Ethereum merge. Yeah, we worked on different things. There were like different client teams. We would have to, do a lot of, dev nets. I remember DevNet 0 to DevNet 5. And yeah, so it's going to come soon. So, but I want to emphasize on why I joined Shardeum, right? So, all the things I was thinking in Ethereum, okay, why they didn't actually do it, like a lot before than now? Why are you thinking about, sharding, scalability, that? Now, why they didn't do it? They actually thought, but they didn't implement it. They were so focused into this one that it became like a big oil tanker, right? So to actually turn an oil tanker, it takes like several miles to actually change to change the direction of an oil tanker. But if you are a small boat, you can just change it immediately, right? And then in Shardeum I saw that all these things were done from the beginning, from the start, ground up. Like we all know everything. So this is how innovation goes. And I decided that I want to do this. That's why I came here, right? So, okay, so I want to go to previous slide. So this is how I looked before I went into blockchain. And this is how I look now, right? So just for you, if you search and see some nice cute guy, that is still me, but that's also me. So before going into, I'm sure most 90% of them are like, maybe even 100% know, or at least have heard about scalability, trilemma. But actually before going into that, I want to, actually go to lineage of that a little before. Somewhere in the 80s, people actually, they actually theorized something called as cap theorems. People who are in distributed system, they know cap theorem, right? So they actually theorized that if you build a distributed storage system, especially, you will have either consistency. You have to pick either between consistency or actually partition tolerance or availability. So this was the theorem. But we all know that Web2 exploded and people have to store data. They started to ask questions like, hey, do we actually really want atomicity? Do we want to use RDBMS? Do we want to use the old systems that still respect this? Do you want to have like very strict, constricted rules around the system? Then they started saying, no, we don't need atomicity, right? I don't care. I just want to store something, get something. That's it. I don't want something like an RDBMS which has like a, on-delete cascade kind of, real stuff and all these things. I don't want transactions. I don't want all these things. I just want put, get, do, search. That's it. Finish. So then, they started to actually, build system around this, which can do all three in some form. Like for example, consistency became eventual consistency, right? If you look into like Bitcoin, right, it can do, it does a fork, because in Bitcoin there is like, it's not one authority that can create a block. Bitcoin, Ethereum, whatever, like proof of work system. Any authority can create a block, and the block propagates, and then if there are two blocks that comes here, then it becomes a fork. Then at the end of the day, you have like a fork choice algorithm to pick from that, right? So, and then you think, right, okay, so, at the end, you have like, a plan to merge, and then it becomes consistent. So that's why exchanges ask you to wait for 20 confirmations and all these things, right? So exactly like that, this was actually picked up from Vitalik's blog. So they say he first actually theorized this. I'm not sure about that, but at least he actually popularized it, right? So it actually, he said that you have three attributes in actually a blockchain that you need to have like a good blockchain. One is scalability, decentralization, and then security, right? Now you have you have systems in all three forms, right? You have systems which are like a BTC ETH, which are secure and decentralized but not scalable. You have decentralized and like scalable system, which is multi-chain ecosystem. Like you have like one chain for doing that, one chain for doing this, one chain for that, and then you have something interchain transactions and all these things. Then that becomes a point of a failure. So if you actually take over one chain, you essentially take over all the chain, right? So that's the security that we are actually losing there. And then you have very high TPS chains, which are new generation chains that you are seeing, 50,000, 1K, 100K TPS and all these things. These chains actually do something called as, they slowly, leave out decentralization, and they have something called as delegated proof of stake. That means all citizens are not same. Everybody is not same. I cannot run a validator. It's like saying that, instead of everybody has exactly one vote, if I say that, no, if you have 10 lakhs in your bank account, only then you can go and vote for an MP or an MLA. It's like saying that, right? You actually take his right to actually do these things, right? So these kinds of systems, they give very high TPS, but they actually leave out on decentralization. So, having actually said these things, it's easy to build a system with only two of them. It's hard to build a system with all three, but not impossible, right? That's where we have to, slowly the third generation systems are actually going, right? When I say third generation, the first generation is actually Bitcoin. Second generation is Ethereum-like systems, which is programmable. Third generation are systems which are coming new, L1s. I'm sorry. So, yeah, so, okay, if it is solvable, how? So, one of the ways that is very popular is called sharding. That's how it is done, right? Now, what is sharding, right? This is is it like a new thing that they have done for blockchain? No, this is more than 30-year-old things that you are thinking. If you are looking at, if you are if you are old like me, you would have worked in systems where you have like an RDBMS. Okay, I think there is something there. Okay, so you have an RDBMS which can scale up, right? And then okay, I have maxed out only 8 cores and all these things. Now what should I do? No, I still want to actually expand. So then what people do is that manual sharding. That means they put one more RDBMS and take some data from here and put it there. And they actually do it on based on a logic. In telecom, we used to do okay, all numbers starting with 91 will be in this database, 92, 93, 94, 95, like that. So you have 10 databases, and you have a backend which knows that, it looks at the first 2 digits and go to the database and get that information. And then you have to coordinate between 2 if you are making calls and all these things. So these kinds of things. So this is called sharding, right? And then came automatic sharding, and then came Web2 systems, NoSQL systems, which actually break your stuff and send it to different places. So this is not new, but so this is what is actually the likely path. I would say this is the organic path that all blockchain should take to actually achieve more actually scalability, I would say, and like ST, which is a scalability trilemma, is actually extension of all these things. Okay, so you look at different types of sharding. So, like I said, manual sharding is there. Like you could shard manually and say that all addresses starting with 01 will be here, 02 will be one shard, like that. And then you have a fixed amount of sharding. like example Ethereum, what they proposed is like 64 or 68 shards initially, and then we will have all of them in that. We'll split the data like that. And then you have like, semi-dynamic sharding, which is like you say that, okay, I have like 10 shards now, each shards have 100 nodes, and if I get one more 100 nodes, I will create a new shard. The creation can be using, forking the software, and things like that. But true dynamic sharding is like it has to actually shard based on existing conditions in the network, and it should not matter in which shard that you belong and all these things. It should be too quick to move from shard to shard that it's like it should be easier for doing dynamic sharding. So that's one important thing that I want to push. One example of this is like, I would say earliest example. So there are different kinds of sharding. So one is execution, one is like data sharding or actually state sharding. This is what Ethereum uses terminology. But under the hood, you have to shard a compute, storage, and then actually bandwidth. Right? All three of them you should shard. Only then it will be true sharding. Otherwise, it won't be true sharding. So like there are some examples. Zilac, for example, they did sharding on execution, but still the data all node has to hold the data, right? But they could actually do different transactions in different shards, but all nodes still has to hold the data, so it's not data sharding. Ethereum, for example, they did only data sharding, or they are going to do only data sharding, right? Execution sharding is something that I don't think they will do, because it is very clear from VB that he will not that he will want to scale in actually layer 2, and he want layer 1 to be like security stuff, like for all layer 2s, and scaling will not be part of Ethereum at all. If you want to scale, you can only scale using layer 2. That's what they say. So that's an example of data sharding. Enter Shardeum. So as actually the name suggests, right? So we actually started to do sharding right from the ground up, right? So if you see actually sharding is like actually first class citizen here. It's not like an afterthought that you have to do this and things like that. It's actually EVM based, right? As you say, that was very important for us. See, I would say a lot of people think innovation as like, okay, I create a new electric bulb. That's innovation. Of course, that is innovation. But usually 90% of innovations are, you take something already existing and then you join in a way with a simple step of innovation such that it gives huge boost, right? That's what, examples of that are like strewn around us, like Honda, for example, Shikora Honda. What he did is that he took a motor that is already existing and then joined to create a motorcycle. That's example of innovation, right? So we actually don't want to, it's there already. So EVM is like very standard. It's very clear. There is no ambiguity in that. We don't want to go and shake the ecosystem and all these things. So that's why it's EVM based. And I would say one of the most important things in this one is that it actually, so in this one, unlike any other blockchain, at least I don't know any other blockchain. So in this one, for actually every node you add, you increase the TPS, right? Like actually a Web2 system. You have this 3-node system, you will have a certain number of read and writes, and you increase that 4, 5, 6, and that's how we become distributed systems. I mean, in Web 2 world, that's how we know it, right? You work on Hadoop or anything like that, you put more nodes in HDFS, you have more capacity. Like, that's how it is. That's how the world knows it, right? But it's not like that in blockchain. If you have 40,000 nodes in Ethereum, you will have like 400,000 nodes in Ethereum. Ethereum will always be 15 transactions per second. But that's not good for us, right? You can go to L2 and do all these things. I'll come to L1 and things like that. But this is important for us, that if you want to actually scale, you have to have this increase per node, right? So this is some of the things that we are doing. I'm not saying only we are doing, but these are some of the things we are doing for a long time now. So linearly scalable. What does that mean? Exactly as I said, right? So the more nodes you add, shards get adjusted and shards get created, and in a TPS you could see increase linearly. We have actually showed that in Q4 presentation or Q4 demo last year. You can go and see that in YouTube. And then actually dynamic sharding, as I said, you have a static sharding at one side, and then you have like, I have like, a sharding which is like semi-automatic. We had sharding where you want to do a fork. You have sharding, you have to do a lot of things, but a true dynamic sharding does not have any parameter that actually does it. It takes actually the load of the system and sees what it wants to do, and that's how shards are created. So as a user, you don't have to think about which shard I'm going to actually deploy my contract and all that such, because this will be keep on changing, right? And then elasticity. This is my favorite. Okay, so this is like, you actually increase the number of nodes in the system or decrease the number of nodes in the system based on the total load that is actually coming into the network. This is something like we are actually very proud of, right? So this is elasticity. So I could just grow. How grow? We have like standby nodes. You can be in standby for some time, and then we would actually pick it up and like increase as and when. So if you have like a suddenly CryptoKitty is coming on, boom, it goes up, right? And then people will add more nodes. It'll just keep on increasing. You don't have to change the code. No fork, no hard fork, nothing. It exactly works like same thing, every time. So this is elastic nature. And then when it comes to sharding, people talk about contract composability. That's a very hard problem to do. Very hard problem to do, right? So one of the philosophy that we actually believe is actually not keeping things in block or a transaction in block. We actually don't have a concept of a block. Every transaction is actually processed individually, right? So it's actually a sort of system where you could just give transactions, and then they have their own finality, and then it gets processed. Every oats and everything is only for that. So we have all these things only for that transaction. So this is how it's done. It's not done in block. So to do a cross-shard stuff is actually to create a consensus group like this. I have a consensus group which is a shard. I have another consensus group which is another shard. This is actually shard A, shard B, and a person 1 wants to send, who has an account in shard 1, to actually, and then to like another account which is there in shard B. So what we do is that we actually join these two things, and then we create something called as a consensus group, something called as a transaction group. That means all the thing will be shared between them, and then these things are, we exchange stuff, and then we actually do a vote on that, and then it says, yeah, it's done. So this is actually formed dynamically, right? Ethereum actually does this every slot. In ETH2, if you take ETH2, you have a slot. The slot is 12 seconds, and then you have like, I think in the 32 slots, it's actually an epoch. So every 12 slots, it actually picks a group of this thing, but it's done on a epoch level. So you pick a group of guys, and then they vote on the block and all these things. It's very similar to that, right? But this one is, this becomes easier for you to do contract composability. That means one contract can exist in this shard, another contract can exist in this shard. I can actually call from this contract to that contract and all this stuff. But that's done. Because we are working on like an individual transaction level, you get the atomicity of the transaction even if it's across the shards. So you don't have to think about like, okay, if I want to build a DeFi application and I depend on a contract, I have to go and deploy in that shard. So what will happen is that over the time the shard will become fat, and like some shards will be very lean, and then we'll have the same problem, right? So that's the thing. And then EVM based, I mean, I will not explain this because this is like super obvious stuff. You know, we can inherit a lot of things, wallets, development tools, all this stuff that you use to, Solidity, Viper, all the things that you have, it will exactly work exactly like that here. Right? You don't have to do any change. We want to make sure that the developer has absolute, like very clean onboarding when he comes to our system. It doesn't have to change a bit, right? It just works, right? That's what the experience that we want to give, and like, yeah, we want to inherit that. Who doesn't want to? Okay, I'll talk about fairness a little bit. Fairness is like, I mean, it's actually a feature in other systems where you actually do a front running, right? You would have heard about the word front running. I have a transaction which is doing something, and then if there is some, and then there are like actually big operators who look on the mempool, and then they see that this transaction is going to get something, so they actually create a transaction, give little high fees, and they execute that. So first, right? So it's like skipping the queue by just giving 100 rupees darshan, and then you go like, without the queue, and all free darshan are standing on the line. That's not right. I mean, we think that, we have to treat everybody equal. And we have a fairness thing where we do transactions based on timestamping. Not the timestamping that you give, but the timestamping that actually the network picks and assigns to that transaction. So it's all ordered based on that, right? So that's how we achieve fairness. Low gas fees. Now if you look at the gas fees, I mean, it's actually a very simple equation. On one side you have actually the size of the network, capacity of the network. On the other side, you have the fees. If that capacity is constant, then if you have more demand, then you have to give more fees. But if you actually reverse it, if you have like elastic capacity, right, this one will almost stay same and low and things like that. You don't need to actually give more fees or tip or anything like that, right? Here to like go front and things like that. That's what we call fairness, right? It's actually fairness in transaction, and actually as actually a side effect of that is on fees. You have very low fees because of that. Okay, so you talked about all these things. What is the basic hardware requirements? For a normal validator node, it's very small, it's very thin, right? We were actually running things in 2-core things, but we recommend a 4-core machine. I mean, like a couple of GBs, very small amount of storage, in fact. and then a decent bandwidth. That's what which you have in a home, that should work fine. We work in something called as OCC model, which is open, collaborative, and community-driven model. That means that from the starting, from the beginning, right from giving the name of our testnet, everything is picked by the community. Even the pitch deck was written by the community, right? And our website, all the things, logos, everything was done by community. So we include community in actually everything. We have open sourced most of the code. Some of the code is not open sourced because we are actually doing a defensive, patent on these things. We don't want large organization like Credit Suisse or like some other guys coming into us and then saying that we invented this first or we patented this. You can't use this in a public chain. So we don't want to actually have that. And like once it's done, next quarter, we will actually go and release everything to open world. Right? And like they can do stuff on this. Right. So, okay, so you said a lot of things, but how did it actually solve the, the trilemma? So, I mean, when I say, okay, we are scalable, that means we are scalable in terms of, TPS. That's what scalability means. How many transactions can you actually consume and things like that. When I say decentralized, that means that we consider all the validator nodes as equal, right? You don't have to have like huge nodes to become a validator node, which will actually take out most of the people out. It's a very small requirement. You have a very small requirement of proof of stake on that. And so, I mean, all of them can join, right? So we treat everybody equally. Whether you have more money, less money, all validators are equal for us. So and then very important thing is actually security. How do you actually take care of that? One is actually network-wide security. You make sure the network is functioning right, and that's done by like proof of stake. Another is like actually transaction security. So when a transaction comes, what happens? I mean, like we form a quorum and then we form a transaction group, as I said. And then they all do a vote on that. There is a receipt that is being stored exactly like EVM. In fact, EVM receipt that's being stored, as part of the transaction. So it goes to every EVM on the top. It actually runs in the EVM. EVM validates the transaction. It gives back the results. We actually go and share that as receipts. We actually collate these receipts. I mean, if you know it too. They do the exact same thing. But this one is slightly different, where you do this for every transaction because you want this to be, very soon finality, right? Not wait for like a block and then you have another block there, but it doesn't have your B portion of that, your 2 portion of that. So you have to somehow make sure that you actually pick transactions which are going to both the blocks and all these things. That's crazy to do that, right? That's how we have it. And then also our joining procedure. I mean, you can say that, okay, what happens if I take over your shard? Your shard size is maybe 128. What happens if I actually take over your shard? You can't take over your shard because when you actually join the network, it's actually the network that assigns you where to go, right? So that means to actually take over the shard, you have to take over the entire network, which is like, more than 51% if you, this thing. Initially, it might be possible some large organization, if they want to bring us down, yeah, they can do that, like Ethereum and things like that. But we still have things in place which could, proof of stake has like, you have to put your stake in that, right? So it'll be actually economically expensive for them to do all these things as the network grows. So as the network grows, it will be very difficult for them to do that. I'll go for the next slide. Okay, so this is the thing that a lot of people will ask, why a new L1? Why can't you do an L2, right? And as I said, innovation, it actually happens in iteration. You have first Bitcoin, Bitcoin was like your old Nokia phone 3310. You had only 3 or 4 apps called contact, this, that, that's it. You can't add your app on that. It's like you have your operating system plus app built on that, right? And then you had the second generation system which said that, okay, so I'm exposing things to you outside so that you could build apps on that. You have iOS and Android. It's like that. Ethereum is like that. But then, the third generation system, our system, what it does is that it splits even more. It's like saying that, I don't know if people have used kernel, before they had dynamic loading in Linux. So what you have to do is that if you actually write a device driver, you have to recompile the kernel itself and then actually run it, right? So now what happens is that the consensus layer and execution layer, all these things are together, they work like this. But now what we have done is that we have actually made it very clear. We have a network layer, and then we have things on top which are like device drivers, and one of them is EVM. So EVM sits on top like a device driver. So you could build your own device driver. Tomorrow you could do plug and play and all this stuff. All right? So that's one thing. And then actually second thing is that actually the speed to build all these things, right? It's easier to build from scratch than taking, I was saying somebody that, doing a merge in Ethereum is like actually changing the engines of Boeing 737 over the Pacific, right? It's like that. It's very hard, very, very hard. So I said, when I came out, I said, this is one of the hardest of the things that I have worked in my entire 25 years. It's very hard to do that, right? But in this one, since you're starting, you could adjust, you could have test beds, you could do a lot of things, and then there will be iteration 4, 5 things, I'm sure. That's how after 10 years you will have like one network. You will not even think about all these things. Nobody will speak about these things. Next is important. Roadmap. As I said, we have been working for a long time. The base layer is like we've shown that it is actually scalable. In Q2, we formed a Shardeum foundation. This is where we put EVM on top, started testing that. We have AlphaNet out now, and then we are doing private sale, to get some money. Yeah, I need money, some money. So to get some money, and then in actually Q3, we are going to launch BetaNet, where anybody can actually download the software and can run the validator, right? And then you could do that. So this is like it's like a test net. You will have a faucet, just get it and then put it, and then you can run a validator check. Now, what you can do is that if you are a developer, you could actually take your stuff which is there in Ethereum, just put it here. We have the same JSON RPC also here. You could just actually shove it here, and then it should work. Right? It should work exactly, except that it will be speed, faster. And then we are saying that we will go for mainnet in actually Q4. There will be SHM token generation and all this other stuff that I don't want to talk about. So, yeah. We are going for AlphaNet, 2.0 tomorrow. So I would ask you to, go register yourself. So in previous AlphaNet, we had 15 TPS network. This would be like 100 TPS network. Please try it out. Tomorrow is the launch at 4 p.m. UTC, if I'm not right, but please check on there. And then I would say actually this is the best time to build in Shardeum, right? We are open, we are listening, we can react fast. We can do a lot of things, right? And like you could be like an early adopter of these things. There are a lot of things, important, that being an early adopter is like, so important in some places that, you feel very dejected later on that why didn't I do this? Like your father saying, I didn't buy the land, it was only 2,000 rupees, now it's like 2 crore rupees, so sorry, kind of feeling that you should not have. So I would say this is the best time to build it. Okay, I think that's it.
I'm curious.
Thank you very much.
Thank you.
I know I would have exceeded the time, But yeah, if you have any questions, I would be in my booth. Please come there. I'll be really, really happy to speak to you guys and give like we can have a chat and things like that. Plus, we are looking for some nice developers. Thank you very much.
Come on, guys, give it up for him. Give it up for him. Give it up for him. Make it louder. Come on, guys. Let's get the vibe back in. Zahoor bhai, the moment you said that's it, I'm like, is that a question or is that a cue? But then, thank you for that fabulous session. So, guys, did you enjoy it? Yes. All the devs in the house, make some noise. Quite a bit of devs. Not bad. Not bad.
Wag me.
Give it up for him. Give it up for him. Wag me. We are going to. For the guys who don't know the meaning, I think you should please step out. For the guys who know it, say it out loud. We are going to. We are going to make. Thank you. And in fact, so when you go out to his booth, I think he just looks old school, but he is a total Web3 degen. Look at the chappal, look at the vibe. You know what, Mirko? You know in Chennai, what do they call a friend? What do they call a friend in Chennai? What do they call a friend in Chennai? Macha. So he's got the total macha vibes. Thank you for keeping the macha vibes. Thank you, everyone. Come on, guys, give it up one more time. And before we go, I think we should take a selfie with the coolest macha in the house.
Oh yeah.
Let's take a selfie with the coolest macha in the house. We're going to upload this onto Twitter and all of that. But everyone out there, how did you do with that?
Wag me.
Wag me. Everyone, put this up, put this up, put this up. Can you stand up for me? Can you stand up for me? Please stand up. Let's go crazy, guys. Come on, this is Goa, yeah. What were you expecting in Goa? Show me this. Okay. So I will do two things. I'll take a video first because I'm a YouTuber, so I love videos. Okay. So when I'm going to say the coolest matcha in the house, wag me. Okay. Super. And then we'll take a photo also. So just keep standing like that. Okay, aa jaiye sir. Well, if you're thinking where we are with the coolest matcha in the house. We are going to wag me is the nara here. Okay, let's take a picture. Everyone, wag me. Very nice. I really love the growth of your beard. मेरी तो उगती भी नहीं है.
Thank you very much.
Welcome. Thank you so much. Thank you. Lovely.
Okay, so this was the last slide. So if you want to follow us, come to our Discord, and this is the place to build your own dApp on Shardeum.
And go to his Discord and give him a shout out, the coolest matcha in the house.